Hello everyone and welcome to Tech Tuesday number 5. This week we'll be talking about how the internet works. It's going to be again a very quick overview. There's some important key things I want you to understand that will help us as we discuss how to be safer on the internet as we move along. So last week, if you missed it, we talked about how the internet works and how it's interconnected through a system of backbones that have a high bandwidth and interconnect smaller networks until we get to our homes, which are not represented on this map but would be off of the little dots down on the actual map. And of course the backbones are in white. That's the really high-speed interconnections between different service providers and primary network connections. This map I showed you last week was both a representation of how active the internet is and also how vulnerable we are to attack and mischief when we're on the internet, because all the 500,000 or so folks who participated in this were not necessarily willing participants as they monitored the amount of internet traffic they had. So still like this graphic, it's an important thing to remember that you are never completely safe when you're actually on the internet. So this week we're going to talk about these letters you may or may not have seen before and expressions. TCP IP. Everybody who's on the internet is using this TCP IP set of protocols to communicate with other computers. TCP, of course, stands for Transmission Control Protocol, and IP stands for Internet Protocol. And we'll go into this just a little bit. I'm not going to go into detail on this, but I do want you to have at least a passing familiarity with what these terms mean. TCP, or Transmission Control Protocol, breaks data down into pieces. We talked a little bit about this last week and how when we used to use the telegraph and then subsequently the telephone, the communication was in whole sections. It was an analog, and so there was no breaking it apart and putting it back together. It was basically just one wire, one communication, one connection between one point and another on a telephone or a telegraph. With TCP, Transmission Control Protocol, data or information was able to be broken down into smaller pieces and then sent out over whatever route worked using IP, which we'll get into in a minute. TCP controls the sequencing and reassembly of these packets, since we are breaking things down, and then it does send the information out using IP, which is Internet Protocol. So you do not need to memorize this or be in any way familiar with how this works. This is kind of a diagram of the data that's sent out from computers to other computers. But the key thing I want to point out to you here in all this mess is the blue line and the orange line that says source IP address and destination IP address. The key thing to take away from this graphic is that every piece of data that you send out over the internet, whether it's voice or text or pictures or programs or whatever, every piece of it, every single piece, has a source IP address and a destination IP address that can be traced back and forth. That's the key thing you need to take away from this diagram. So if you're under the illusion that anything you do on the internet is in any way private, that is just an illusion. Again, we talked about how the internet was designed from the beginning to be robust and to withstand outages anywhere in the network system. And the trade-off for that is every single piece of data that you send out is going to have an identifiable IP, and both as a source and a destination. There's no way around it. So we can talk more about that later, but this is the key thing I wanted to point out to you here. As you look at this graphic, just know that every single piece of data that you send out is going out with a from and a to address. We'll talk more about that in a minute. So we're most familiar, if you're familiar at all, you're most familiar with Internet Protocol version 4 or IPv4. It looks, if you look at the top line there, the top bullet, it says every device has an IP address when it's on the internet, and it's going to be in some form of four-digit numbers. For example, it would be like 111.51.13.255. This is very similar to how phone numbers work, where you have an area code and then an exchange number and then an actual contact number for you. There's 256 unique possible numbers in each of those four spaces, which if you multiply that out, ends up giving us just over, theoretically anyways, about 4 billion possible unique IP addresses. Now in the 70s and early 80s, when actually in the 70s and 60s when this was being thought out, that seemed like way more than enough, way more than we would ever need. As it turns out, we exhausted all those addresses. In other words, they were all dispersed and in use as of the year 2011. So that created a problem that they saw coming from about the 1980s. So we'll get back to that. But this is kind of a visual representation showing you that when you're sending from something from your computer, from your laptop, from your PlayStation, anything that's connected to the internet, it has a from address, which is your address, IP address, and then a to address to the location that it's sending it to. And again, that gets back to that IP address stack that we saw earlier. So here's the thing, I'm going to keep saying it a bunch of times. Everything that's connected to the internet has an IP address, an Internet Protocol address. Everything. There is nothing out there that doesn't have an IP address. And this is I'm just going to say this several times during this little talk this week. They are transitioning. We've been into it just over 2 years now, the IP version 6. This has a much greater range of IP addresses, and you can see the XXX:XXX. So it's a different format. There are 8 groups of numbers there. It actually uses hexadecimal. I know that's getting way out there, but it's 8 groups of 4-digit hexadecimal numbers. So in other words, each place on the number has 16 possible digits instead of 10 in base 10. So that ends up being over 65,000 numbers, unique numbers per space or per group. So it ends up at 3.4 trillion different possible unique addresses, and hopefully that'll get us through for a while. Long after I'm gone, will they need more Internet Protocol addresses unless something else has come up. So this diagram here shows kind of, I couldn't really find a good graphic to show a typical home setup, but I'm going to use this one because it's the best I could find. And don't pay attention to the actual specific names like it says Huawei, HG5. That doesn't matter. The point is, at home, most of us are connected to the internet with some sort of a Wi-Fi system or a switch system. So that thing, whatever it is connecting to the internet through some sort of router or whatever. But the point is that you have so many devices in your home you're probably not even aware of that are actually connecting directly to the internet. You see on the left there the Nintendo Wii. You've got if you have a satellite system, satellite TV system or cable TV system, it's possible it may be connecting to the internet. Again, you have a PlayStation 3 or 4 now. Your computers are obviously doing that. A lot of printers do. So you may not even be aware of how many devices, and what's not on here is other wireless devices like your cell phone, which connects to Wi-Fi at home, probably your tablet. So any given home is likely to have many, many devices connecting to the internet, and you're probably not even aware of it. And another thing that's missing from this diagram is our smart TVs, which are, of course, also connected. If you have Apple TV or Roku or any of those other streaming devices, they are, of course, connected. So your Wi-Fi system at home may be handling a lot of connections that you're not even aware of or haven't really thought about. So here's the key thing I want you to take away from this week. Everything connected to the internet has a unique address. It just does. While you're connected to the internet, you are vulnerable to attack, and sadly, the only way to be completely safe is to be disconnected from the internet, which sort of negates the point of having the internet in the first place. We'll talk about some ways to be safer while we're connected. Coming up, we've got firewall and other things like that I think will be of use to you to have some understanding of how that plays into this. But